Chapter 3, Measurement and Dosage Calculations. Learning Outcome 3-1, Solve Problems Utilizing Fractions and Decimals. Please read through the next few slides on fractions. Please pay special attention to this slide, such as 1.0 equals 1 and 0 over 10 equals 1. 0.75 is 75 over 100, so that's 3/4. 0.66 is 66 over 100, that's 2/3. 0.5 is 5 over 10, and is 1/2. Please make note of that. Learning Outcome 3-2, identify the most common equivalents among apothecary, metric, and household measurements. Please notice how the apothecary system uses a minim and a grain. The household uses a fluid ounce and an ounce, and the metric system uses a meter, a liter, and a gram. Learning Outcome 3-3, solve Fahrenheit to Celsius temperature conversion and vice versa. In this slide, you can see that Celsius is found by taking the temperature that you currently have in Fahrenheit, subtracting 32 from it, and then dividing it by 1.8. That is what equals Celsius. In this slide, you can see that to solve for Fahrenheit, you need to take 1.8, multiply it by the temperature that you currently have in Celsius, and then add 32. That's how you solve for Fahrenheit. In Learning Outcome 3-4, you're going to learn how to calculate the number of tablets, capsules, and injectable medications to give when the available dose differs from the ordered dose. Here we can see that D is the desired, so that's what the physician orders, and we're going to divide that by what's on hand, right, which is the H, hand, the medication you have on hand. Now, X is what you're solving for, that's what you're looking to find, right, and the V is the vehicle. So is it a tablet, is it a liquid, what is it? Any way you look at this, we are taking the dose that is ordered and dividing it by what you have on hand. And that is how you're going to be able to say, okay, this is what I'm solving for. This is X. And then you're just going to put whether it's milligrams or milliliters, right, behind the numeric number. So let's take this drug calculation problem, for example. The physician orders 250 milligrams of a medication to be given PO. What does PO mean? Per oral. And it says stat. What does stat mean? Immediately. You have 125 milligram tablets. How many would you administer? Well, we take our we take what's ordered, right? And then we take what we have on hand. So what was ordered? 250. There's your 250 right on top. What is ordered? Sorry, what is on hand? 125. We put that under it. 250 divided by 125 is, let's find out. Let's go to the next slide. And here you go. 250 divided by 125 is 2, right? So you need 2 tablets, right? That makes sense? So let's try another one really quickly. The physician orders 50 milligrams of an elixir. Available is 100 milligrams per 5 mLs. How many milliliters would you administer? Okay, this is easy. So we take our 50 that's ordered and we divide it by the 100 that we have on hand. Okay, well 50 divided by 100 is what? Does anybody know? 50 divided by 100? Okay, let's go to the next slide. Okay, so let's look at this. So you've got your 50, you're dividing it by 100. Now you know you're going to get, right, because 50 is half of 100, you're going to get 0.5. Now, this is per 5 mLs. That means we're going to take that 0.5 that we just had, and we're going to multiply it by the 5 mLs. So 0.5 times 5, right, is 2.5. Okay? Do you see that? So now our answer is 2.5 mLs. So let's check this one out. The physician orders ibuprofen, which is Motrin, 0.3 grams per oral BID, that means by mouth twice a day. Motrin 600 milligram tablets are available. Okay, super. So this is where learning all of those, like 1 gram is 1,000 milligrams, really kind of comes into play. Okay, so this is where we're at. So it says the first thing you do, you must convert, right? 0.3 grams is 300 milligrams. Let's talk about that for a second. 0.1 grams is 100 milligrams. 0.2 is 200. 0.3 grams is 300, right? 0.4 is 400. 0.5 is 500. I hope that helps you. Write all those down, and you can do the same thing for so from grams to milligrams. You can write down the exact same chart and just change grams and milligrams to milligrams and micrograms. It's the exact same thing. So anyway, so we've converted our 0.3 grams to 300 milligrams. Now we know that the physician ordered 300 milligrams. We have 600. 300 divided by 600 is, right, 0.5 again, so it's half. Right? All right, and then so right there you can see we're supposed to give them a half a tablet. Let me know if you have questions on that. So learning outcome 3-5, calculate a child's dose of medication. Discussion board question for this week. What is the difference between adults and pediatrics? And don't just tell me that they're small and we're grown. But what is the difference? What is the reason why we have to calculate out a pediatric dosage of a medication? What do children do differently with medication than adults? Answer that question, and I would like it in 1 paragraph, 1 in-text citation that is not your textbook. Please put that in APA. No cover page is necessary. Now, that being said, 2.2 pounds is equivalent to 1 kilogram. Therefore, 20 pounds, right, would be 9.09 kilograms. What I want you to focus on is if 2.2 pounds is 1 kilogram, then that also means that 1 kilogram is 2.2 pounds. So how do you do the math on that? Well, if I've got a patient who weighs 15 pounds and I want to know, well, let's try this again, 15 kilograms, and I want to know what it is in pounds, I would take my 15 kilograms and I would multiply that by 2.2, right, to get the pounds. If my patient weighed 30 pounds and I want to know about kilograms, I would divide it by 2.2. So here we go. Let's jump right into this. The physician orders Dilantin for a 22-pound child. The appropriate dose is 5 milligrams per kilogram per 24 hours. How much Dilantin should you give in 3 divided doses? I know that sounds like a lot. It's not that bad. Let's start at the beginning. The first thing we need to know is that it says milligrams per kilogram, right? And we have a child that's weight is in pounds. The first thing we have to do is convert the pounds to kilograms. So we're going to take the 22 pounds. We're going to divide that by 2.2, just like I told you. And now we have 10 kilograms. Okay, there we go. So now we know that it's going to be 5 milligrams, right, per every 10 kilograms in a 24-hour period. Okay, good deal. So we're going to see, so next step there, 10 kilograms times 5 milligrams equals 50 milligrams in a 24-hour period, right? All right, now, how do we get it into 3 divided doses? Easy peasy, right? 50 divided by 3. It's not that hard. So we have 3 divided doses, so it's 50 milligrams, right? So 50 divided by 3 is 16.7 milligrams per dose. And that's it. That's all there is to it. Do you have any questions about that? Let me know. Okay, so here's this thing. There's a thing called a safe dose range, and not every medication is safe at all times for children. Sometimes the doctor will say, okay, give them 200 milligrams of this medication 3 times a day, and you look up their weight, and it's only safe for them to have 150 milligrams 3 times a day. So, because children, that's that question I asked you that you need to do in a discussion board. Why do children need different dosages of medications than adults, and why is their weight so important? That's something that I need you to look into. So that being said, this right here helps. To figure a safe dose range, right, you need to know what's safe for that child based on their age and their weight. So it says, is the dose safe, right? And this problem right here walks you through this particular medication, but the long and short of it is we have to make sure that the range of the medication is in, per the manufacturer of the medication, is safe for that child to take. Learning outcome 3-6. Calculate drops per minute for IV therapy. In this calculation, you can see that volume in milliliters divided by time in hours multiplied by calibration or drop factor divided by 60 minutes equals the rate. That's GTT, which is drop, per minute. So let's take a look at this IV calculation problem. The physician orders 1,000 milliliters of normal saline to be given over 5 hours. The drop factor is 10. 1,000 milliliters divided by 5 hours times 60 minutes, right? So 5 hours, 60 minutes, okay? So that's 5 times 6 is 30. So that would be 300 minutes, right? Multiplied by 10 GTTS, because remember, that's our drop factor. So 3,000 multiplied by 10 gives us 33.33 drops per minute.